Good afternoon, sir. Good afternoon, sir. Here is Pratibha Pandey. Sir, please wait for 2 minutes because
Good afternoon.
participants are joining, sir.
Good afternoon.
Thank you, sir. Could I start the session, sir?
Sure, go ahead.
Okay, thank you, sir. Good afternoon, everyone. Today's session topic is surface construction. Now I welcome our expert, Professor Dr. Niranjan Swarup, sir, Director General of Indian Society for Trenchless Technology (IND-STT). He is BTech in Civil Engineering in 1987. He has been involved in various infrastructures development projects. The assignments handled by him have ranged from design, estimation, project planning, and execution. In addition to being a trenchless technologist, Professor Niranjan Swarup is also a formally trained arbitrator from Singapore International Arbitration Centre and lead quality assessor under ICQ project of European Council. He is currently the board member of various professional bodies like Engineering Council of India (ECI), International Council of Consultants (ICC), and the Council for Application of Actuarial Science in Risk Management in construction and aligned industries. He also represents India on the board of several international organizations like Asian Forum, Asian Concrete Construction Institute, International Council of Consultants. He is nominated member of several consultative committee like Bureau of Indian Standard (BIS). He is the member secretary of several task force and working group for different bodies. The prominent of them are the Jawaharlal Nehru National Urban Renewal Mission and National Council for Vocational. Professor Niranjan Swarup sir Professor Niranjan Swarup sir is one of the prominent trenchless technologists recognized internationally and invited to speak at most of the international trenchless events world over. He has, to his credit, several trenchless publications. He is the editor of Node Dig India Journal and regularly contributes articles in the international trade and technical journals. He has contributed substantially for the information of code of practices for installation natural gas pipeline of BIS. In addition, he has developed code of practice of several trenchless techniques like directional drilling, horizontal earth boring, and pipe jacking. He has edited and authored several books and training manuals related to construction and trenchless technology. He has been responsible for initiating several trenchless courses titled Surface Utility Manager, Trenchless Pipeline Manager, and post diploma courses in trenchless technology. Additionally, he is now initiating several courses on SSEM, pipe bursting, and other trenchless subjects. He is also involved in establishing trenchless technology research and education centers across India. The first of them is now being initiated at Vidisha, Madhya Pradesh, titled National Habitat Center on Surface and Trenchless Technology, Research and Education Centers across India. Now being initiated at Vidisha, Madhya Pradesh, titled National Habitat Center on Surface and Trenchless Technology under partial grant funding of AICTE. Recognizing his contribution to the trenchless construction industry, Singhania University accorded him the title of Doctor of Philosophy in the year 2012. Welcome to you, sir. Now you can take the session, sir. Thank you so much, sir.
Thank you, Pratibha. Pratibha, is my presentation visible or is it the screen? Is my presentation
Sir,
visible?
no, sir. Presentation is not visible, sir.
Not visible? Okay. I'll have to switch over to another computer because this is not. Now, Pratibha, what is visible?
Yes.
Yes, sir. Your screen is visible, sir. Now.
The subsurface construction.
No, sir. The screen is visible. Your presentation is not
So,
visible, sir.
presentation is not visible.
Yes, sir.
Okay.
So you can share it, sir. Your presentation is going to share.
You have to share also.
Yeah, I'll just go on.
Open the PPT, sir.
It's actually open. I'm logging on to from
You
another.
give share screen, sir.
Sir, click on share.
Yes.
The share option is available on your screen. Please click on share.
I clicked on share. It's only showing. It says window. When I say window, it only shows. Oh, this is crazy. Because this is not showing the screen actually.
Sir, first open the PPT.
Yeah, I'm just putting it on another computer.
Okay.
Is my screen visible now?
Yes, Professor.
Yes, sir.
Yes,
Now
sir.
it's
Yes, sir.
now it is.
Just give me one more second. Okay. Now we are on the screen.
Yes, sir. Now it's fine.
Sorry for this hiccup. Actually, I was trying to do it on Mac Air, and Mac Air looks like it's not allowing it to move. All right. So what we are talking is subsurface construction, and this is the faculty development program under ASLAP. I have discussed about subsurface construction in the previous two editions, and this edition also I'm talking about the same. Now, the difference here is that earlier I was talking about creating a vision document. Here I'm talking about creating the manpower or creating the professionals, and the faculty members have great role in that. So let's move on. First of all, the bottom line is underground space is the future of urban settlements. We need appropriate vision to preserve it for our future generations. The land what we have received, the underground space what we have got is from our ancestors. It belongs to our coming generations, and we don't have any right over it. We are just custodian for that particular space. Now, my presentation is structured into 6 parts: background, subsurface space, trenchless technology, subsurface constructions, academic initiative needs, and then finally concluding remarks. Let's go to the background. What I want to discuss or talk with all of you. Trenchless technology is the family of a subsurface construction techniques that help in remotely constructing, maintaining, or replacing subsurface utilities buried below the ground surface without excavating continuous trenches. In the national context, trenchless techniques have an extremely important role both during the construction as well as later during the operation, maintenance, and replacement at the end of economic life. So you start with the cradle and reach the grave. From cradle to grave, you have application of trenchless technology everywhere. As the urban area managers, which we engineers are, it becomes imperative for the engineers to have sufficient internal capabilities for construction, operations, maintenance, and replacement of buried utilities, both conventionally as well as through trenchless methods. Conventional methods, all of you are teaching as faculty members. I'm talking about merging that with the trenchless methods so that we give our learner or our student or the professional that we are creating a holistic approach or a holistic vision. Through this capacity, the nation would be able to get subsurface utilities developed and managed efficiently and effectively. Prerequisites To achieve this capacity is to have proper vision for the application of trenchless technology in the development, maintenance, and management of subsurface utilities, as post-construction management and maintenance of buried utilities through the conventional modes may become challenging and even impossible in certain cases. For capacity creation, we need our academic institutions to see ahead and include systems to cultivate students capable of rendering services for such engineering requirements. I want our engineers or our students who graduate from our colleges to be capable of delivering such services to the nation. In this talk, we shall be looking at different aspects of subsurface constructions, their risks, their failures, why they happen, and then the vision attributes and modes to create national capabilities and put them to use in nation building. There would be talk about how the system fails or why the system is failing and how do we correct it. So let's go to the second section, which is subsurface space. Using subsurface space is the primary need why what we are talking here. So it's basically the location and land use pressures which force us to go underground. Say you are living in a metro and metropolis and you require to create a mass rapid transit system. Now MRTS or MRT or whatever we call that has to either go overhead or has to go underground. Now, if you go overhead, there are always limitations about creating the infrastructure. For an example, I was there to inspect the Kanpur Metro last week or last fortnight, I should say. The Kanpur Metro main line has been constructed from IIT Kanpur till Moti Jheel till now. Now, the station at Moti Jheel had to be constructed almost touching the buildings on the left side. On the right side, this lane is built parallel to the railway track, and everything is installed on the columns, and those columns have the footings which were getting inside the railway track areas. So it was a challenge to construct that, and I would really say that this was overcome under Corona and all those pressures. They could do it, but then it is not the normal case. You need to go underground comfortably, and if you're doing subsurface, it's easier. You go for environment preservation. That if you are doing the same MRTS below the ground, obviously you are preventing the degradation of environment. You isolate the things. The same example which I gave, you isolate the MRTS if you had put it below the ground, and beyond Moti Jheel, Kanpur Metro is being constructed underground. Topography, there are topography needs for which you use the subsurface requirements. Like if you go to Madurai, part of the city is on elevated grades. You go to Haridwar, Dehradun, all these are partly buried below, partly elevated and partly lower sections. Now to merge them, you have to go underground. And then if you are laying a pipeline, say you are bringing oil, gas, or any other major material transporting across the nation, you may be crossing rivers like Ganga, Yamuna, Godavari. All these rivers have been crossed umpteen number of times, and every crossing means you have to go below the ground and you use the subsurface space. Now, what are the advantages generally? When you do it underground, time is saved, flow of private vehicular traffic is reduced surface land consumption is there, more space for pedestrians, urban development and utility management issues are addressed, and then reduction in external or social costs like noise, pollution, congestion, and accidents. All those are indirect advantages of an underground. These are commonsensical items. I just put it so that they come into the perspective what we are discussing. Now, what we need is the optimum use of underground space. Mind it, the surface what we have for any urban area will have a finite space below the ground. You have to install all your structures, utilities, basements, your pipelines, everything in that contained area. They have to installed in a way that the community's need is met. The benefits of underground is maximized. The use of benefits are maximized. It should reinforce the positive features of surface environment. Take for an example, if you are building a tunnel with tunnel sections, like if it is a segmental tunnel and they are simply placed there, if you will excavate anything below that, there is a possibility of this particular tunnel collapsing. To prevent that collapse, you'll have to sort of use it in a way or construct it in a way so that the whole mass remains stable. You go to many of the developing nations or developed nations, the pre-stressing of the sections or the tunnels sections are done so that anything excavated below can be placed. Now, we have to use the geological setting in the best manner and plan and design for the future use and sustainability. This is an example which I gave you about the pre-stressing. Once that pre-stressing was done, and I'm talking about a project in Hong Kong. In Hong Kong, one metro was laid, and then below that, another metro was laid. The upper section was pre-stressed, even the lower section was pre-stressed, and the composite was available so that anybody could lay anything below that. In Singapore, there are tunnels or there are drainage systems which are called DDSs, Deep Drainage Sewerage System, which is about 60 to 80 meters deep from the ground surface. So you can imagine the kind of possibilities what we have for underground space usage. Now, if I talk about conventional construction methods, what we will do is we will vacate or we will kind of excavate the section. This basically means the surface is disrupted, the damages to the adjacent structures could be there, the cost and duration of work relative to the above ground structures and construction. If there are mini structures, it becomes extremely expensive because you'll have to have confined excavation, you'll have to have all kind of protections and everything. Mechanization gets increased because of deeper installation. You have made a city, all the utilities would be laid at certain reference level. Then if tomorrow, if the city owner wants to increase the number of utility or increase the capacity of the utilities, they will have to either enhance the same capacity or lay another pipe. So obviously that pipe will go below the existing one. So later the utility is constructed, the depth increases, and all those basically make the conventional construction quite difficult. The challenges of cut and cover methods become more enhanced when we are talking about already settled or already created areas. In India, we have the urban cities already developed and in which we are creating infrastructure for future. For the smart cities, for an example, we are making smart cities where there are gray areas, or rather gray field, they are green field. So that gray field is an area where you have the utilities already existing, in which you have to create more utilities to serve the future population and all. So all those things make the conventional construction challenging. Now, just a last slide on the problems with a cut and cover. The underground space in the public right of way is heavily used. Traffic congestion is growing by day, every day. There are numerous vehicles being sold or purchased in India, and all those vehicles are ending up on the street. There are more pedestrians or users. They are coming in. So the congestion is growing. The street pavements are getting damaged if you go with the cut and cover. The cost of surface restoration goes up, and the direct and indirect business losses of the institutions which are close to those excavations are extremely high. So these are the common problems what we face with the cut and cover. Now, I have constructed my utility. Now what? If I make a pipeline, will it survive for the whole life of me? It may not. So what is the next step? The next situation is the buried pipelines get damaged. Why do they get damaged? There are numerous reasons why the structure will fail, the pipeline will collapse. And if the pipeline collapses, these are some of the outcomes if you see. This is a picture from Arbindo Road, Arbindo Marg in New Delhi, where the pipeline collapsed, and along with the pipeline collapse, all the roads collapsed. Or you can see this is a picture from, I think, Hyderabad and Chennai, I think, where again the same thing happened. And you can see the kind of damages which are happening. The roads are sinking and the caves in are happening and the vehicles are getting in. And these accidents or failures are becoming commonplace these days. Now, another commonplace thing you can see is the combined sewer overflow. You have the sewerage lines which are choking. and which are unable to drain off the material because the siltation is happening inside the pipeline, and the fluid or sludge what you are pumping in or you are throwing in gets extruded from the pipeline or sewer lines, and it overflows on the street. So it's also a common feature what we are seeing. Then we are building right, left, and center everywhere CGD, city gas distribution lines. Now, can you expect this kind of accident happening? If you don't expect, then you're not really caring. These kind of accidents have already occurred, and they would go on occurring if we don't manage and maintain our subsurface space. See, ultimately what happens is that a system will fail. You have a pipeline, its joints or its connections or its components will start leaking, giving way. Cracks and leakages will permit the fluid to come in. If you see, it is this particular slide where my mouse is moving. So when the fluid comes in, it will bring the soil along with it. When the soil moves, you'll get a soil void, and that soil void, when loaded by the vehicles, will collapse, and then ultimately you have these things getting in. The picture in the center and the picture at the right hand bottom are from Gurgaon. So you can imagine that this is not a foreign land picture. This is happening here in India, and especially in monsoon seasons, these are possibilities. As an engineer, our business is to stop these happening. How do we go about it? But then the question is, do we want our subsurface infrastructure built to serve us, or do we want to continue serving them rather? Choice is these two. If we want to be in the first group, we want to get it done. We need to have professionals who are capable to deliver these kind of requirements. And that is where my talk is taking all of us. Please think about it. Please try to create these kind of programs in your curriculum, these kind of modules in your programs. Run special packages and let the boys and girls learn about that, so that we can create a capable manpower for civic infrastructure in India. Now, let's go to the basics or definitions of trenchless technology. Trenchless technology is a set of techniques for the remote installation, rehabilitation, and repair of utilities, pipelines, and small tunnels linked by their lack of need for digging a continuous trench, for the installation of new structures or their repair. What I do is I will create a subsurface space without excavating anything above that. And that basically helps me to protect everything which is above the ground, and at the same time create my cavity. So this is what is the generic definition of trenchless technology. You do it for creating a cavity, that is called new installation. You do it for repairing the cavity's liner, that is rehabilitation. You do it for removing or replacing the cavity, which is called replacement. But all these are governed through techniques or logics that how do you do it? You need to see through the ground. So all that is linked to seeing through the ground. So this is what are the 4 sections of trenchless technology, which we would like all the faculty members to kind of bringing into their academic activities as well as practical activities. Start working with the consumers or end users for this. Let us look at these methodologies one by one. New installation technique means creating a cavity in the ground. So how do you create the cavity? You can shift the soil sideways. You can cut the soil mechanically and remove it axially, like a auger train, you can say. Or you pump fluid, and that fluid pressure dissolves the soil, and the soil is kind of extracted because of the fluid flow, fluid pressure, and that basically creates the cavity. New installation trenchless techniques apply these utility construction methods in isolation or in combination. There are many methods to do that. Let's talk about rehabilitation. Once I have created a cavity, naturally to protect my cavity, I have placed a liner or a pipe or any material or any structural material which can take the load. Now, this liner, after certain usage of certain period of usage, will start giving way. So what we can do is we can kind of prevent the leakages. So we plug the leakages, or we insert a membrane so that if the longer sections are damaged, the membrane can stop. But in case if my pipe or the structure which I have been constructed there is failing, then I can insert something which can take the load. So first is plugging, second is providing a leak-proof membrane, and third is providing a leak-proof membrane having structural strength. These are the three possible ways in which pipelines can be rehabilitated. And there are many methods utilizing these in isolation or in combination. Now, in case if your pipeline has lived its economic life, then what happens? Your complete section will fail. And now what you are going to do? Either you excavate or extricate that and place a new pipe. In urban areas, that is not possible. So what you do is you kind of use that space by going through the existing space and creating another pipeline. That is called replacement. Now, in replacement, what you do is you can take some kind of bursting tool inside the corroded pipeline, and that bursting tool breaks, and the old pipe gets pushed out in the soil, and the pipe is pulled in. So that is first mode, that is bursting the corroded pipelines from inside. You can split the corroded pipeline by running a knife through it, or you can implode it by running tools which can crack and crush and bring it inside the axis of the pipe, or rather axis of the cutting equipment, and then you extricate that material. So replacement trenchless techniques use these three liner replacement mechanisms. Now, seeing through the ground means you go for subsurface utility engineering processes where there are standard set protocols which define how the subsurface utility information is gathered, it's quantified, it's designated and reported. So those methods tell you if your pipeline is buried below the ground. There are many geophysical methods like ground penetrating radar, pipe and cable locators. These are all engineering methods which tell you that there is a cavity in the ground, and that cavity is documented under the protocols of subsurface utility engineering. So those protocols help you in getting the maps of the ground on a real-time basis. And if you get it on a real-time basis, you can plan your project in a way that your machines, your cutting equipment, or your repairing equipment do not go and damage it. Beyond subsurface utility engineering process, there are geophysical investigation processes where you have these GPR, as I indicated earlier. All those GPR, there's seismic refraction, seismic reflection, there's tomography. All those are conducted to find out the geophysical situation of the ground. And finally, if you have an existing pipeline, you conduct the pipeline condition assessment processes, which goes from running the CCTV camera mounted on a robo, or you go with various other pipeline condition assessment methodologies. There are numerous methods, and all of those are part of the seeing through ground processes. Application of trenchless techniques must be done on the basis of information collected from these three method groups individually or in combination. So this is how you create, you manage, and you maintain your subsurface utilities. Now, what are the implications of trenchless technology? Cost versus depth. As we are talking about entering the ground at one location, coming out, creating the cavity and coming out, or entering the ground at some location, repairing or replacing the utility, and then coming out, it is independent of the depth. Whereas when you go for an open cut or a conventional construction methods, the deeper the utility is, the expensive it will start becoming. You should remember that utilities will occupy larger zones of underground, and accordingly it has to be planned. It can interfere with the future large-scale underground structures, and somebody has to plan accordingly. Even in Delhi, we have made interceptor sewers at a depth of 25 meters. Remember it, the cities like Chennai, where these kind of things are quite needed, and very soon we would be building pipelines and tunnels at that depth. Mumbai, we are already building north, south, east, west pipelines for drainage. You can see the effects in what we call that uh, Methi River. The Methi River is almost on the surface, and half the monsoon time, the sea flows into Mumbai rather than flowing out of Mumbai. Then there are social cost impacts, like if you are not damaging anything on the surface, you are kind of preventing and protecting people on the in the battery area of your construction. So obviously there's a social cost which is saved. And then there are utility systems accommodated to change the new methods. Say for an example, we are talking about smart cities. We have existing pipelines. They have to be altered to meet the current IoT, Internet of Thing, information gathering or information management systems. So obviously all those things can be done through Trenchless technology, and that is where we are promoting Trenchless technology with the smart cities in an extensive way. Now, let's go to the subsurface construction. On subsurface constructions, subsurface works are executed in non-homogeneous media full of challenges. Possibilities of failures and accidental damage to existing subsurface structures are a very close reality if the trenchless application is erroneous. Errors possibly could be erroneous subsurface information, unsuitable techniques, unmatched capacity equipment, poorly skilled operators, or poor quality materials or consumables. For a successful project, one needs to remove such errors, and that is where our faculty members or our professors, our lecturers are needed, so that they can educate our students that look here man, you have, or look here lady, you have to remove this particular error. And how do you do it is something which has to be understood and trained. Now, if I am looking at a utility means a pipeline or any structure which is providing some kind of service to the users. So it has 5 phases of life cycle. You plan and design it, you construct it, you inspect and maintain it, you rehabilitate and renew when it's going slightly bad, and then when it is reaching its end of the economic life, you replace it so that you can use the same subsurface space again. This basically leads to new installation, rehab and replacement, seeing through the ground, and life cycle data management. Because remember, any city would have miles and miles, maybe 1,000 miles or 1,000 kilometers of pipelines. Delhi has something around 9,000 or more buried pipelines inside the municipal areas. So you can imagine the database management and how do you do it. That is what is one more major business in Trenchless. So what you do is, when you're talking about planning, you plan the routes, investigate the site, visualize how your structure is going to function, design for construction, and design for life cycle. Once you have done the designing, you go for construction. So you conduct the construction process as per the specifications, needs, or technique requirement and the site constraints. You update the site model that you visualized in the previous stage and avoid damage so that the things function properly. And finally, create the construction records, or the term is called ABD, as built drawings. You create as built drawings so that tomorrow somebody can go and check your structure and get it rectified or repaired in case of any damage. Then comes its data management under inspection and maintenance part. You have low cost sensors installed so that you can know where your structures are buried. You have smart materials. They can inform that this is the location. There are RFID tags that are placed. There are many more telltale signs that will tell you these are the benchmarks and how do you find it. And then you create a feedback of the performance of structure that you have created. So that is the inspection and maintenance. Then comes predicting the deterioration, that how your pipeline is deteriorating. Manage the asset for that particular process. When you are rehabilitating, gauging something, whether it's really just leaking or it requires a small liner, or it requires a structural liner, because each selection will have its own implication of cost, time, and efficacy. If your pipeline is just partly leaking at locations and you go in for a heavy structural replacement, you are wasting money. Vice versa, if your pipeline structure has collapsed and you still go for only plug leaking, you're simply wasting the money, because whatever you do, end of the day, it'll again start leaking, or the road collapses, other things will continue happening. So you select the method, and then once you do that, you upgrade your record, because your material would have changed or the material configuration would have changed. So you update the record, and then finally you go for the replacement, where you do the asset management just like the previous one. Detect the utility, because what utilities you have constructed today might have been hidden in the ground. People would have constructed something over it. There are many cities I am aware of where the manholes or the sewer lines are included inside or encroached upon, and drawing rooms are functioning all over it. People are living over it. So how do you find it? So that is what is another business of Trenchless. And then finally, design for replacement and upgrade the records. So this is the brief utility cycle, and how do we go about it. This is one understanding which I wanted to convey to you, so that in turn you can convey this to your students and let them think over it. Now, if I'm talking about engineering, the process is of this cycle. You define the need, you generate alternate solutions, you evaluate alternatives and select the most suitable solution, you do the detailed design, you do the design promotion, that this is what is the design you have to do, and discuss it with people or discuss it with the stakeholders, so that you know that because of myopic vision, you might not have made some mistakes or made some errors. Construct and test, evaluate the performance, and finally report the conclusion. So this is the cycle of design process or engineering process, which our engineers or students have to understand or know. Now, when I'm talking about underground, the challenges what we face are basically geotechnical. The geotechnical issues are, there is uncertainty. I can have a ground surface which can be flat. I can have a ground surface which is undulating, but then the upper may be the flat, but the lower, there can be layers of different levels, and that would basically bring much of uncertainty in the construction process. I can do my borehole checking at one location, borehole checking of another location, and there could be just change of situation just besides them, and I would not be even knowing that. So that is another issue, another challenge. Appropriate expertise and timing are at times missing, because the experts may not be available, and that is where we need to create our boys and girls, so that this expertise is inculcated in them. Then comes the contractual sharing of the risk. There is, when we are talking about underground construction, there are always risks, and those risks have to be addressed and contractually shared. So what are the processes? And this is something which are need to be inculcated while my boy or girl is studying with you. That time itself, if I tell him that this is what a contract should look like, he would be more inclined or open and understanding the whole process. Then comes funding for investigations, because if you're talking about geophysical, the people will not be happy to spend money. So all that comes as a geotechnical issue. Then comes the technology. Technology is something, because we are talking about a term which is called state of the art. Each project would be designed, planned, promoted, and executed based on the site conditions. So it would have some challenges. The primary challenges are the works are remote. You are running a machine at a location and it's working somewhere below the ground at a distance. So it's a more remote operation, less direct observation from the ground conditions. You can't see what is actually happening below the ground. The life cycle approach to the design and management of underground structure has to be seen, and then the greater use of CR technologies is there. So these are the technology issues, and this is where your inputs come in. May that be civil engineering, may that be material engineering, may that be mechanical engineering. You name the engineering, and you need to be, you have some piece of pie in your hands. It can be computer science, it can be CSE, it can be electronics and communication. Everything has a role in trenchless technology or subsurface construction. Trenchless technology applications are remotely operated, smart construction processes that are extremely useful for creating, maintaining, and managing subsurface utilities without continuous excavations. Through this feature, surface and subsurface infrastructure destruction in urban areas can be avoided during construction. In addition, positioning, processes, and systems of these techniques can help in creating correct as-built database or as-built drawings database of buried utilities, providing valuable input for future maintenance works of subsurface utilities. I'll just mention one case about Kolkata. In Kolkata, close to about 1901, 1902, the drainage system was constructed where the pipelines were as huge as 8 feet diameter. They were brick barrel sewers. And the drawings which were created were created on the scales being used at that time. Those sewer lines, those drainage lines are still functional. And now it's very difficult for many of the authorities. There are multiple authorities handling those drainage lines. It's very difficult for them to actually find out where those buried lines are, because there are people who used to come and tell that, look here, we buried our pipe at this location, or we found the pipe at this location. Now, all those things in future is not possible. What we need is a complete, robust database that can be banked, that can be used, and that can be upgraded as the time flies. Yes, Mr. Shamla Prakash, you have asked a question? Hello? Mr. Shamla Prakash, you have raised your hand. Okay. We'll go for the question answers once we complete this presentation. Utilities like water supply, drainage, power and telecom lines, petrochemical and gas, transmission and distribution networks are commonly buried below the ground surface. Historically, these have been laid by conventional open-cut processes where you excavated a trench, filled up with sand, put your pipe or put your structure, covered it with sand, and then covered it back with the backfilling. With enhanced density, the subsurface network trenchless techniques are becoming preferred or almost only options in many situations. Works, however, are becoming difficult with the passage of time and growth of subsurface utility densities. Those utilities are growing on a substantially fast pace. Trenchless project failures are culminating several issues and need to be addressed adequately. Needs to address them adequately. Now, when I'm talking about trenchless project failure, the failures occur because there are many methods I explained about the rehabilitation. Same thing goes for new installation, same thing goes for replacement. So if you select an improper technique, the project can fail. If you are doing inadequate site and soil investigation, you can fail. Inaccurate subsurface interpretation. See, what is happening is, it is unlike seeing something and drawing on the surface. If I'm making a contour plan, I have certain tools and equipment which will give me the result automatically, or maybe by applying some kind of normal surveying technique. But when I'm talking about a buried pipeline, there are bound to be signatures available only. If there's a pipe buried below the ground, I would be running a ground penetrating radar over the pipe. And what would happen is that this radar would be sending a signal which would be hitting the pipe, reflecting, sending, reflecting, coming, reflecting. This would create a parabola or a what do you call a signature parabola of this utility. Somebody has to interpret that what is the meaning of that parabola, and for that you require understanding of this particular process. So subsurface interpretation is challenging. Then comes unforeseen ground conditions, because you planned a project and did not foresee what is the ground condition. Like there have been cases in Kolkata where the tunnel boring machine unfortunately pierced in a water body. And this is, I'm talking about a failure in Bau Bazar area of Kolkata in the recent past, where the water entered, gushed in the tunnel, and maybe continuous line of houses simply collapsed. So there are unforeseen ground conditions which were not actually visualized. Damaging existing utilities is a very, very commonplace. If you are looking at the trenchless works happening in your area, you may find that some contractor would have come and damaged the water supply line, and the area would get flooded. Some contractor would have come and damaged the optical fiber cable. And if that has gone down, that means your internet down, your telephone down, many things down. So damaging existing utilities are one of the causes of failure. And then getting an equipment which is under capacity and using it on a job. Say if you are trying to push something, your thrust capacity is say 100 tons and your resistance is 150 tons. It will never be able to go. Even if it is 100 ton and you're pushing using a machine of 100 ton, still it will fail. So under capacity equipment choice is also another cause of trenchless project failure. Next is temporary structures, that is inadequate temporary works. There are enabling works, and if you are not doing it properly, they can lead to project failure. Installation of inappropriate or weak material in your project, failure to adhere to the work or material specifications, and inappropriate or bad workmanship. My business, and as a professor, your business is to create manpower which do not end up in projects like these. That is what is the call. Now, if I simply go to the anatomy of failure, what I'm talking about is that I started my work, I failed to complete the installation, I failed in providing job site safety matters, I damaged the environment, natural or other above ground structures, the surface collapsed or heaved, I started pushing and something went up. Hydrofracture or inadvertent drilling fluids or effluent started coming up from the ground. And then I damaged the other utilities. So this is, broadly speaking, the anatomy of trenchless failures. When I'm talking about failure to complete the installation, that basically means if I'm creating a bore. So it's basically a reason of bore failure. When I'm boring something, I need to provide it lubrication, I need to provide methods to remove the excavated material. So that is done by circulating the fluid. That circulation, if it is lost or loss of circulation, material stop coming out, the project will fail. If there are obstructions in front of my machine, the project will fail. If the hydrolock becomes, there is always a hydrostatic pressure in the ground. There's water table and there will be a pressure. And if your pressure and that pressure matches, you may not be able to push further. The hydrolock is that particular situation where it's locked hydraulically. The line and grade failures, because if you want to lay a pipe at a certain depth and alignment and you go below or you go above, you'll never be able to reach this location. So let's say if you're crossing a river or rivulet, you started at this level, want to reach this level, but you ended up here. You failed. The borehole or cavity collapsed while you are drilling or you are cutting the thing. Your pipe collapsed or drill pipe or downhole tooling failed. So these are you are raising the hands. We'll go one by one once I finish the presentation. So for success, what are the essentialities? It has to have a minimum horizontal and vertical clearance requirement, because if I'm cutting some soil or if I'm using any material, the pressures will be there and I need certain space, working space, which can be clear. The road setbacks and existing surface features and existing underground utilities, these have to be understood and planned accordingly. The product pipe and associated tooling diameter requirements, the alignment geometry for the ground profile, the trenchless equipment requirement for the geological conditions, equipment and materials handling requirements, and material strengths, capabilities, and joining methods. So these are the essentialities of trenchless projects. Now, what would be the critical inputs? Please mind it. My point of my idea of including these bullet points is to give you thinking points or give you directions where you can create the programs, you can create modules, you can create questionnaires, you can create quizzes for your students so that they can start having the ideas how to go about it. The critical inputs for the trenchless projects are the trenchless attributes that we will be talking just after the slide. Required attribute of executing agency, what are the required qualifications or criteria of the party which is executing the works. The technology selection, how you select the technology. Execution plans, how do you plan the project or execution of that. How do you inspect the project. There are challenges in new installation. There are different challenges in lining, and there are different challenges in pipe bursting or replacement. So those are the critical inputs when I'm working on certain project, and each one will require a separate thought process to go in, and we need to create our students according to that. Further comes these when I'm talking about attributes, the trenchless technology is a specialized business. हेलो, वो इंटरनेशनल उसमें भेजा, हम लेक्चर बताते हैं आपको, देख लीजिए ना पॉइंट इमेज में है. He has to be trained by some international body or something. हाँ देख लीजिए, SIAC का उनका ओपी गुप्ता की इशू है ना खाली. अच्छा हम लेक्चर दे रहे थे हम सॉरी, I'm sorry. So then comes technique selection that have to be seen. The operators shall have or should have specific skills, and those skills are quantified, defined, and those should be there. The equipment has to be suitable. The material needs to meet the project requirements, project construction as well as usage requirements. The technique related limitations need to be understood. If you are using some methods which can, for an example, lay a pipe without any grade and alignment control, and you are using it to lay a pipeline for a gravity flow pipelines, that would be a failure. So there are always technique related limitations, and we have to see and understand that. Proper subsurface data requirements, and then impact on the surrounding structures. If there are structures besides your project in your battery area, naturally there are bound to be issues which can come and create problem for you. When I'm talking about executing agencies, there are basically 4 primary attributes one has to have. The knowledge and experience to execute such projects, appropriate equipment capable to execute such projects, adequately trained and certified operators, adequate capabilities for subsurface investigations or an access to the same. So these are primarily the 4 attributes, and naturally we can have basic understanding in our students that when they are working as a employee of the executing agency, what kind of things they have to cultivate. If they are working as an employee of a utility owner, what are the attributes they have to see in the agency, and if they are working themselves as an executing agency, this is what they have to cultivate within them. When I'm talking about project control or project management, that basically goes with the planning, permitting and easements that you permit, because you're working in the ground and you're working in a multiple owned land. So obviously you'll have to have easements and permissions. There are risks involved in construction activities, and especially when we talk about the underground construction, the risks are higher. So risk identification, their mitigation measures, all those have to be understood. The alignment has to be designed. When I'm putting a pipe, either I'm pushing the pipe or I'm pulling the pipe. So there are bound to be certain axial thrusts, there are bound to be certain frictions on the surface, there are bound to be loads coming in, there are bound to be water table which is pushing it down. So all those will generate some kind of stress on the pipe. So that pipe stress has to be understood. Directional accuracies are important. There are methods by which you can install your pipe in a precise 0 or maybe plus minus 25 mm tolerance. And then product pipe considerations. So those come under project considerations. Then comes planning. When I'm talking about planning, planning goes for overall project requirement, which is the product pipe diameter and material, length and depth of the crossing, work site and access conditions, feasibility of trenchless methods and equipment usage, pre-planning and mapping, which is computerized and alignment planning. All those are possible and are done. When I'm talking about job site safety, is basically operator skills. If the operator is skilled enough, he will prevent the accidents. If he is not skilled enough, the accidents can be galore. SHE, that is safety, health and environment issues are there. Job site inspection and briefing has to be there. Overhead structures, when you're talking about putting or pushing something in the ground, there's a possibility that your boom or your equipment is going to go up and it may hit something. There could be overground structures when you're transporting your material, they could come and foul with it. So all those need to be understood. Underground structures and appurtenances have to be located, understood, and planned. The work has to be planned according to them. The trenchless and allied equipment safety is a premium requirement, because if you do not understand that, you are talking about hell. Take for an example, if you are drilling in the ground and God forbid you go and touch a power cable, a HT cable, your drill rod will get charged. And if the drill rod gets charged, the charge will come till your machine. And God forbid, if your operator does not know, what he will do is he will jump from the machine and start walking. If that happens, the charge will pass through his body and he will die immediately. There are basic methods that he has to understand, that this is how he has to work. Those accidents are not very common, but then those accidents do happen, and there are equipment to stop that. And that is called electrical strikes. So these are the job site safety issues. Then we come, when I'm talking about proper project planning and execution, I should have the basic trenchless project consideration, how the project is to be executed. That basically means I should know the trenchless construction method for a particular process, and then plan according to that. My alignment has to be known and work has to move according to that. Take for an example, if I need to lay a pipe which is 2 kilometers long, and in Kanpur, Ganga river has been crossed with 2 kilometer length. There are new now projects which are 8 kilometers long in Northeast, where the projects are going to start. And we need to have understanding, or our engineers need to have understanding to execute such kind of jobs. There are directional accuracies and tolerances. The product pipe considerations are there. That let's say you are talking about, imagine if you're trying to pull a pipe which is 2 kilometers long. Think what kind of consideration has to be there. All those come into picture. Then there are stress considerations, and then finally, as-built drawing considerations, that whatever you have constructed has to be recorded and kept for repair, maintenance, and operations later. When I'm talking about equipment operator, his key performance standard include safety while he's working. He has to understand the working drawings and execute the work accordingly, because if he has not understood it, possibility is that the drawings which are prepared by doing the subsurface utility engineering would have told him or would tell that the pipeline or buried structures are here, and he would go and damage them without understanding. So he has to know the working drawing and sketches. He has to do that execution in compliance with the drawings. He has to have the appropriate use of equipment and tooling. He should know that. The machine operating procedures and sequencing, and meeting the minimum qualifying competency standards for the operators. Those have been frozen. Those are hosted on our website. You can have a look at those, and those need to be transferred to our students. The next one, or finally, comes the academic initiative needs, which I want to convey to all of you. I want you to take a call on that. Now, the national need and future trends are, urban floodings are happening right, left, and center. In the monsoons, there are people simply claim that this year the monsoon was biggest in the last 10 years, 15 years, 20 years, 30 years. But the fact of life is the areas are getting flooded. And why they are flooding? Because the evacuation systems of those pipes are not able to service the city. So this is one of the growing need which we have, and we need to address that need. Operation and maintenance of existing infrastructure assets. Do you know that we build close to about 4 lakh crore rupees of construction assets every year, out of which about 1 lakh crore goes under the ground. Subsurface construction is close to about 1/4 of the complete investment. For the last 25 years, we have been investing 4 lakh crore rupees in today's price lines. And that basically means we are talking about 100 lakh crore rupees for this whole period, out of which 25% is subsurface asset investment. So imagine the kind of repair, maintenance, and new installation is required to service and maintain that. Who will do that? Our students. And who would help them to do it? You people, our faculty members. The smart city, utility operation and maintenance is the next operation. We are building 100 smart cities, and for them to function properly, we require our professionals to work and create infrastructure, maintain, manage them so that the smart cities perform properly. City gas distribution networks. We are laying PNG everywhere in almost all the major cities, and those PNG, pipe natural gas networks, those networks have to be developed, maintained, managed. Who will do that? Our students. Enhance subsurface utility networks to cater rising urban demands. Even wherever we are not having the smart city being constructed, still the areas are being constructed. People are moving in, the urban centers are getting overloaded. This means if you're supplying, let's say, 75 liter per head per day to 10 lakh people, and tomorrow if the population goes to 20 lakh and you continue supplying the same quantum of water, imagine the quantum of drainage which has to be created for them. How would you do it? Naturally trenchless, because your urban areas are already developed. People are living there. You cannot go and excavate and lay new pipes. Then comes major transportation and material transfer tunnels. Like one example, I was just inspecting a project at Kanpur. It was for transferring what you call petrol, diesel, ATF, that is aviation fuel, and kerosene from a refinery in Bina to Kanpur. So all that earlier was being transported by trucks. Then the refinery owners, they decided to lay a complete pipeline of 335 kilometers long, connecting Bina to Kanpur. And their throughput increased 3 to 4 times. They are able to service more areas in UP because of that pipeline. All those things have to be done by our boys. Please train them. On international demand, better infrastructure for cities are also coming in, because it's not only India. Overseas also, there are people who require infrastructure. There are countries where these capabilities have not grown till date. We need to train our boys and girls so that they can go and render the services there and earn foreign exchange for the nation. That would be for improvement and extension of the more developed countries, and basic systems still needed in less developed countries. So everywhere we have opportunities. We have boys and girls going and working in Middle East, Gulf countries. We have boys and girls going and working in Philippines, in Far East countries like Malaysia and all. Indian boys are going and working, boys and girls are going and working. So why can't our students? Some of the future trends would be, one is see ahead technology, where you have the wearable computer on your body and you are walking, and data is acquired and sent so that a complete database is created. There are sensors and data technologies for existing infrastructure where the sensors can move in the pipeline and things are recorded. There are low-cost sensors, as I indicated in the beginning. So these are some of the new technology. Now, because of this demand and those things, what is happening? Either we are training our boys and girls or we are not. In case if we are not training, they are going out, working at a lower positions and then trying to get the professional job at a later date. That learning curve is quite long. If I am able to teach my student while he is with me in the 4 years, his learning curve will be shorter. There is tremendous demand of underground construction. There's an increased market for underground construction, increased imperative for professionals to be more involved in underground space user issues. New geo-related research and technology development opportunities are there. We can have right from mundane at job working to researchers and developers who can find ways and means to create new trenchless technique systems under your guidance. As professors, you can do it. And how do you do it? The subsurface construction require adequate application of engineering inputs. I believe all of you have those capabilities within you. Each subsurface project is different and needs to be planned, designed, and executed to suit the site requirements. Some of the important engineering inputs include specifications, contractual conditions, schedule of rates, standard operating procedures, method statements, subsurface utility engineering code, project supervision, code of practice of drilling. There are in all 7 code of practices that we have developed. I just mentioned 2 here. Then operator competency standards. So these things are extensively needed to create the capacity. For proper project execution, these publications are available. There are several INDSTD training programs to overcome different challenges and cultivate operator and engineer skills. Practicing engineering professionals can enhance their skills and in that way enhance their prospects. And this basically, I have put the slide to let you communicate with your alumni so they can get and train with you, train through you, and start getting that knowledge. Students and entry-level engineers could benefit immensely by learning this technology nuances through you while they are studying in their final year years, the second year, third year, final year. Utility system owners can get help greatly in adoption of the technologies by developing their own capacities with working with us. Now, when I'm talking about capacity creation, to initiate the actions at grassroots, we need to develop systems for creating professionals having sufficient understanding of trenchless systems. Engineering institutions need to become a part of this capacity creation process because we would be working as industry. We need academia to work with us. That could be done through interacting with the local civic agencies or ULBs, that's urban local bodies, and providing them advisory assistance. That will give you some kind of professional work, some kind of revenue for your department, and as well as opportunities to work on the project and give them solutions. Students could be deployed on the project for onward development of capabilities in them. For addressing technical capability gaps, such institution could work with INDSTT, work with me, work with us by establishing chapters at institutional level, as Pratibha was talking about, that Trenchless Technology Research and Education Center. These are few inputs available from us, that is our publications. Other Trenchless publications, some of them we provide, some of them are available globally. There are inputs on the project linked issues. Then INDSTT has a robust member network. They can be accessed and they can help both in getting the things done as well as maybe working with them to train their future employees who are your students. Train your students so that they meet their aspirations, the aspirations of INDSTT members. Go through or run the INDSTT training programs, other trenchless training programs. Then we conduct conferences. The current conference is going to happen on 8th of April. And then we conduct exhibitions. For the last 2 years, we had to move it to online exhibition. This year is going to be again physical exhibition somewhere in December, creating INDSTT chapters. So with this, I'm coming to the end of my presentation. Trenchless technologies offer an effective tool for subsurface construction activities. Due to aging infrastructure and explosive demands, nation will need to develop and enhance its trenchless capacities. Trenchless capacity enhancement needs to address each type of stakeholders involved in the project delivery chain. Engineering professionals are needed to be cultivated to serve this essential national need. Academic intervention coupled with industrial inputs are essence of this objective, and I invite you to work with us. Nation needs to develop its internal capacity for successful subsurface construction projects, and vision documents play a vital role. INDSTT provides a major platform for such activities and provides necessary knowledge for developing the vision. Underground is future. Let's maximize its potential for our future generations. And that's the end of my presentation. Thank you very much. This presentation copy will be shared with everybody by Pratibha after we complete our talk. So now we can open the floor for discussions.
Sir, can I ask one question?
Yes, please.
This is Dr. Polas Pali speaking from Haldia Institute of Technology. It's West Bengal.
Yes.
Sir, actually, my question is that I am from electrical engineering background. Okay. So I am going for HDD, actually HDD system. That means horizontal direction drilling. So there are lots of things can happen in the underground system. Some places maybe sand, some places rocks, some places stones are there. So is there any electrical operating system is incorporated? So this can be control itself if any kind of rocks, stones or sands come during the time of
Execution.
drilling. Yes.
See, the process of trenchless is that you have to gather the subsurface information as best as practicable. Okay. In case if you have simply done boreholes and you expect that you will get the exact strata what your borehole demonstrates, it will be sometimes or in many other times it's an erroneous assumption. What you require is a GBR, that is ground baseline report, that you can create. But then, in addition to GBR, you need to go for geophysical investigation beforehand. If you are running that investigation, you would know. Especially Haldia, I have been there in, I think, January. I had gone there to inspect the BPCL LPG import terminal. And I know the kind of marshy land what Haldia has, which is between the, between the port, Haldia River port, and the BPCL terminal, or rather the IOCL terminal as well. So in that marshy land, yes, these challenges are there, but you need to conduct some kind of ground investigation beforehand. As far as knowing the soil while you are drilling, you can know that soil by excavated material which is coming out. But unfortunately, the moment the machine has gone in, it's already too late. You cannot change it. You need to chart your route according to the survey.
Okay.
The pipeline installation route has to be decided based on the survey report.
Okay.
Right? So that is the essential.
Okay, sir. Thank you.
I would like to highlight that all of you have to submit questions for this presentation. And those questions need to be created so based on what we discussed. So you need to ask few things so that you can create those questions and send it to us for a submission, onward submission to AICTE. So please ask questions. Otherwise, you have my email ID in the presentation. So that will come to Pratibha will share with all the participants. How to prevent soil cave-ins? To prevent soil cave-in, the first thing is that you have to remove the possibility of cavity creation. Okay. How do you remove the possibility of cavity creation? One, don't permit it to happen. Two, if it has happened, grout it so that the cavities are finished, or else backfill it by excavating and backfilling it. Okay. The essential thing is that you need to have your pipeline condition assessment happening on a regular basis, and that will help you to prevent cavity creation around your pipeline. There is one more action, and that happens with when you have untrained or poorly trained trenchless equipment operators, SDD, like I would say. If the operator does not know how to run the machine, he may go and puncture the existing pipeline. And then that pipeline will start leaking and the fluid will go in, come out, whatever. And that can create cavities. So that would be something which has to be controlled by proper supervision. And the machine, when you are drilling, will have gauges, will tell you that this is the earth pressure it is encountering. The moment it pierces a hole in a pipe, the pressure will go zero. And the moment pressure goes zero, it would be known that a pipe has been punctured. So the moment it is known, it has to be rectified. The contractor does not have to run away and hide away. Unfortunately, people run and hide. And that is why this flooding and those things happen. And as engineers, we need to stop that.
Excuse me, sir. Sir, I'm Dr. Santigopal Pain from Holdia Institute of Technology.
Mm-hmm.
Actually, sir, during basically metro tunneling, the large area excavation is going on basically. So maybe some obstacles come in form of river, building, and everything. Okay, we are in case of metro project. So what should be the preventive measures during should be taken during excavation works?
See, I would always harp on the proper ground surface information, seeing through the ground. The Bau Bazar accident, which I cited, happened because there was a water body in front of Bau Bazar in Kolkata.
Yes.
The tunnel was moving smoothly, and all of a sudden, it simply pierced the water body and entered the water body. Are you aware of this case?
Yes, sir. That's why I'm asking.
And the tunnel boring machine went inside the ground. I went inside the water body. The water came in, and all the complete tunnel section which had been excavated of the tunnel, that section was fully submerged with water. And the moment this water came in, the water started coming out of those liners, the liner sections. And once the water came out, it led to the collapse of the buildings in that particular lane in Bau Bazar.
Yeah.
Although people did not die, because the moment this accident was noticed, all the houses were vacated. But ultimately, there was a loss of buildings. And this has, one of such mistake also has happened in Delhi, where again some 21 houses, there the machine moved. They run it on a wrong, see what is happening is that there is when you are doing a trenchless job, it will give you the level value from the surface. Okay. Now, if the surface is going down, dipping, the value will be what we call reducing. Now, in this case, what happened was the ground went up, and since the level was shown higher, this operator who did not know anything, he tilted his machine in upward direction, and because of that change of direction, the machine pierced the ground and came out on the surface and damaged the houses in front.
Yes, sir.
So there are many issues, and that's the reason I said this is a state-of-the-art technique, or each project is a state-of-the-art business. We need to create our candidates, our students, so that they are capable. And to make them capable, you also have to go on a project mode. And how do you go on project mode? Work with the urban local body, municipal corporation, or whichever is in your area. Talk to them. Render them this assistance. They will pay you some fee, and at the same time, they will provide you some business, and that business will basically help your students to learn, enhance the operations of your institution or engineering college. And obviously, as on date, I'm aware that many of the projects simply they go that, okay, we want to go for one specific engineering college. That is basically a prohibitive kind of business. Each court says you go to such and such college, you go to such and such institution. We need to have the local engineering college capable of rendering that service. If you are sitting in Haldia, I know the land there is marshy. There are many issues which you can solve because you have a soil testing lab, you have engineers, you have inputs, and whatever you lack, you can work with us. Get that and start working. Render the support to the Haldia Municipal Corporation, HMC, I believe it's the name. There was a question. Let me see.
Yes, sir. Thank you, sir.
Yes. Is there any hands-on training, certificate training program? Yeah. I just concluded a training program for GAIL, that's Gas Authority of India Limited, yesterday. That's for HDD. It was a 2-day program we conducted. I'm conducting a training program for Mekon very recently. There are regular training programs. Do visit our website. You'll find those. This is the answer to Mr. Manikandan from Passet. See, the bottom line is, please prepare yourself and prepare your students. It's something which will help them to grow and give a very, very good name to your institution. And at the same time, the business would come and that will make your works worthwhile. Because there would be some revenues also coming in. And we work with you, we stand with you. Okay, no further questions?
I think, sir, there is no question, sir.
So we can accept the questions by email, and as well as you have to collect the questions from everybody. So
Okay, sir.
do that and provide the presentation copy to everyone
Okay, sir.
so that
Yes,
they can
sir.
use it.
Yes, sir.
And I request you to please give a acknowledgement of this presentation whenever you are using it.
Now, I would like to thank you, sir, for sharing your valuable time and knowledge. With due permission of you, sir, could I close the session, sir?
Yes, please. Yes, please.
Okay. Thank you so much, sir.